So I'm Arpit Joshipura. I head up open source networking, edge, IoT, and several of the sub foundations within the Linux Foundation. We're really excited to have this discussion with you all. And as you may all know, Eclipse and Linux Foundation Edge have been partnering for quite some time now, and we've already have some press releases around it as kind of the associate membership of LFEdge. And we would love to explore even more specific things that make this unification happen across the edge compute. So I'm going to talk about 35-40 minutes of slides, but as Rosario said, please interrupt in the middle with questions. Raise your hand. I can't see the questions, but I'm sure you can go ahead and ask. Before I get into Edge, I want to make sure people who are not familiar with the Linux Foundation itself, one slide on what we're trying to do, which is very similar to Eclipse Foundation, which is our goal is to create the shared technology investment to help open collaboration across companies, developers, and users. And obviously, we are a nonprofit to help build ecosystems. So that's it. That's what we do. And we are way beyond Linux and way beyond Edge. So we host some of the most critical projects in the world. These projects are in domains like technology domains like security or blockchain or AI, or they're in a market domain like networking, cloud, automotive, edge IoT, etc., energy. And these are just some of the projects we host, about 800 plus projects across many of these sub foundations. So today we are going to only talk about sort of the edge and the IoT domain, and we won't cover the rest, but all these sub foundations are managed in the same way independently within the Linux Foundation. Okay. And I think the way we approach these we host these projects with the developer community that creates products, deployments, and obviously money for end users and vendors so that they can participate. And our job is to provide the neutral governance and obviously the R&D ops, as we call it, plus ecosystem development and support to our members. All right. If most of you are convinced on Edge, I'm just going to talk about a few things on what we are seeing from our community and our market size, right? So the one thing we're seeing is Edge is enabled very quickly with 5G also. So there's a link to telecom, primarily because of the lower latency that comes with 5G. And what we are also seeing is there's a bunch of applications that are driving some of the edge use cases, which I'll talk about. And there's a bunch of verticals that are driving the next battle for edge compute. Okay. Now, the good news is different analysts and different firms talk about how big and which markets and all that. And I've made a list of the end verticals that are impacted by the edge compute. And we see exactly these markets take on the edge compute software frameworks and deployment, right? So, and this is in priority order. So industrial, energy, commerce, retail, et cetera, et cetera. So it aligns quite well with what we see in our developer community and our and the market research. Okay. So what we're going to talk about is LFEdge. As I said, LFEdge is a sub foundation that is organized to establish an open interoperable framework for edge computing. And this is hardware independent, silicon independent, cloud, and OS independent, right? So very important that we keep these solutions away from a particular vendor implementation or a particular tie to the cloud, right? So that's what we are doing. It brings edge communities together. It allows them to interoperate, and it provides, we provide the neutral governance and work with alliances, other open source organizations like Eclipse, as well as some of the alliances, right? Whether it's Digital Twin Consortium or IIC or any of these, to harmonize these critical standards. Okay, so that's our mission, and we cover all of the four markets of telecom edge, cloud edge, enterprise edge, user edge, industrial edge, right? So just keep that in perspective of what we are trying to do. Okay, so now we get started into how we fit into the end-to-end, and we have sort of the three sub-foundations that make the solutions happen, right? There is the LF networking, which kind of hits bulk of it on the core and the cloud side of things, all the way from a control plane up into the applications. And then you have the edge, and we'll go deep into the middle part of the slide. And then you have the access portion, which is everything from RAN connectivity to enhanced last mile access, terrestrial and otherwise, right, licensed and unlicensed, as well as data center and other access connectivity. So we are spanning these things across core, edge, and access. And the reason I'm putting the big picture up is you cannot solve the edge compute problem in a silo. You have access on one side, and you have the core and cloud on the other side. And you need to have these use cases go and cut across these solutions. So if you're looking for a full end-to-end open source only solution, these are some examples. Now, not all these projects belong to the LF. Not all these projects are in LF Edge or LFN, but you can get a view of high level on how these things are structured. So the way we approach this at the LF Edge level is, you take these edge projects, the core projects and access projects, put it into something called a super blueprint, which has 5 use cases: ultra low latency connectivity, mobile broadband, voice services, et cetera, and those get consumed by either enterprise service providers, both cloud and telecom, and end users like government and things like that. And then each vertical industry optimizes for their use in the priority order that I mentioned, right? So industrial is the highest, energy, commerce, retail, home. And so we're going to only talk about the top portion and the projects that are associated with that. Okay, so with that introduction and a high level, let's go double click into the edge. So the first thing that is most important is terminology. So I know you're all researchers and you work in edge. If you can do us a favor and kind of standardize on terminology, we would love to, support you on that. And here's why we say. A year or two ago, everybody was kind of talking about, thin edge, thick edge, far edge, near edge, this edge, that edge, and it was all relative, right? You had to actually ask, okay, so what are you talking about? Deep edge, this edge, that. So the LF Edge community came out, published a couple of white papers, State of the Edge research report is one of them, which is being refreshed for this year. Plus, there's an LF Edge projects white paper. You can download both of these on the LF Edge website. But the community came together and defined the terms in a Wikipedia style definition for edge. Okay, so there's only 2 types of terms or 2 types of edges. There's a user edge and a service provider edge. And I'm going to take a little bit of time explaining this so that we're all on the same page and use same terminology, right? It's very important. So the user edge is dedicated, operated by the user. Service provider edge is shared as a service. And there are 3 implementations of user edge. There's a constrained device edge, so microcontroller embedded compute, smart device edge, so IoT gateway type things, and then on-prem data center edge, right, in a semi-secure location, still under the operations of a user. Some last mile separates it, and then you go across either under the base station or in a smart central office called access edge. After that, we don't call anything edge compute, because if you are not in that 20 milliseconds or less latency, it is not an edge application, right? So if a sensor wakes up and dumps data into a public cloud every week, it's an IoT application. It's not an edge compute application. So there's a proximity angle, there's a responsiveness angle, and a mobility angle to be classified as edge compute. And we want to make sure that we use the terms that are defined below to clearly articulate where the stacks are. And from this, you can already see there is no one solution, primarily in edge compute. Like we have on cloud, you can have Kubernetes, or on telecom services, you can have, Open Daylight and ONAP and projects that are big in nature that everybody in the world standardizes to. In the edge compute, you have different implementations depending on verticals, but at least we have been able to standardize on terminology. Now, obviously, there is infrastructure and application. So that's the other dimension to edge, which we'll talk about in a bit. Okay. So with that background, I wanted to introduce the projects that we have. There's over 10 projects. Each project has its own niche, its own use case, and its own domain. And I'll talk about each and every project in this presentation at the high level. But there are infrastructure projects, and then there's application frameworks. And then they all are either in the constrained device edge or the on-prem data center, or on the other side of the last mile. Now you can see, for example, like Akraino and Beetle are on this access edge side of this equation. And of course, like you all, these projects are at various stages of incubation, just from a maturity and a diversity perspective. Okay, so I want to sort of emphasize that these projects have a developer community. They have an open technical steering committee that you can all participate in. And then some of the use cases, and I won't read all of it, right? But Akraino has a lot of telecom use cases, and I'll talk about the blueprints in just a bit. EdgeXFoundry has use cases in the building, industrial, smart cities, water, retail. Fledge has use cases in predictive maintenance, turbines, transformers, pumps, etc., plus energy subsystems, which have come out, et cetera, et cetera. Okay, so we'll go through each of these projects in a bit. Obviously, we are a global community with a wide variety of premium members. There's a landscape if you want to sort of look at how everything fits in. 66 members, lots of software that's being done, over 2.9K contributors, and we've specifically kept growing in the past couple of years since this was formed. So that's kind of where we are. So to summarize the overview portion of the presentation, LF Edge is about sort of integrating communities across these multiple edge markets with an open and interoperable intent on hardware, silicon, cloud, and even protocol, right? Like there's 150 protocols. There's no one right answer, right? Like whether it's MQTT or this or that, like it doesn't matter. We need to make sure it's agnostic. And you bring the best of these markets together in collaboration with other consortiums, right? And we have formal partnerships with obviously EdgeXFoundry, but from consortiums like IIC, Digital Twin, ACC, OEC, ETSI, et cetera. Okay, so that's kind of a quick overview. And then I'm going to go a little bit more detail into each of these projects. So Akraino is a set of open interfaces and applications which provide a blueprint. A blueprint is a declarative configuration that allows for a use case to be implemented. And it doesn't have to be all open source. It's open source plus other projects plus hardware that the only requirement is it needs to be repeatable and built off open source through a governance structure on how you can submit new blueprints, right? So that's what Akraino is. EdgeXFoundry is a open source framework specifically designed on an IoT edge. Fledge is similar, but for the constrained device edge, and especially focused on industrial. Eve is a virtual virtualization engine, which is kind of abstracted out of the connectivity umbrella. And then, of course, Home Edge is a gateway for home. Open Horizon is there's a very specific lifecycle management. State of the Edge is not a software project. It is a research project that looks at where the market is heading as well as vocabulary. Alvarium is a very interesting trust fabric that allows kind of data from devices all the way to applications through some version of a confidence calculations. Beetle is a cloud computing data services implementation to the edge. And then, of course, eKuiper, IoT analytics, and then FIDO, as we call it, SDO, is a zero-touch onboarding for trust. So this is a quick overview. I'm going to go into detail, okay? Okay, so let's go into the first one, which is Akraino. So in Akraino, we have software, hardware, and process that allows you to provide a set of finite configuration to reduce complexity, right? It's so everybody can implement edge compute and IoT many different ways, but the community has come together and said, here are some examples of the best practices. And here's the documentation, here's the test scripts, here's the software version, etc. So it's a declarative configuration, okay? And it's currently on release 6. I'll give you examples of Akraino blueprints. So release 6 has almost 25 plus blueprints. And as I said, the blueprints have different use case implementation. So there's an implementation for IoT predictive maintenance, or there's an implementation of mech cloud gaming or connected vehicle. One other thing that is very important I want to point out is there is no standards for the interfaces between public cloud and edge compute. So there's a blueprint called PCEI, which is Public Cloud Edge Interface, led by Equinix and others, that actually standardize on that. And I wouldn't say standardize, but standardize with a quote on the APIs on how you can connect to a public cloud, especially from a CDN perspective. Then there's the AI at the edge, autonomous vehicle, right? So there's many of these. You can go to LF Edge Akraino Wiki, just search on that, blueprints, and you can get the software, the hardware, the release status, who is participating, everything in this. So, for example, our folks, our colleagues in China, right? Like they have a connected vehicle blueprint, which is everything from, China Mobile to all the public clouds in China, to the vendors that support it, to the connected vehicles. And they do augmentation of the GPS, right? So for accuracy, for safety, for things like that. So that's a use case that is implemented through the software and scripts that are developed in the LF Edge. So that's the concept of Akraino. And you all can actually participate and submit a new blueprint that is either missing or augment a blueprint with additional software and hardware that you can actually support. Okay, so that's one. And I'm going to go over each of these projects in sort of this like 2-minute thing so that we can have time for Q&A. Okay, but do stop me if there's any questions. Now, EdgeXFoundry, so Akraino and EdgeXFoundry stage 3, so fairly mature projects. EdgeXFoundry is a very interesting IoT framework. As you can see on the right-hand side, it may not be clear, but by the way, we'll send out the slides at the end of the presentation. I know it is being recorded, but Rosaria can send this out if you guys need it. It's an IoT framework with abstractions of the southbound, right? And it's a set of microservices that provide a framework for communications through these APIs and connect to the cloud, right? Very important and to understand that not all protocols and not all interfaces need to, and in all the verticals need to reinvent the wheel of connecting northbound to southbound, right? And so EdgeXFoundry is specifically focused on manufacturing, retail, and building automation. Those are the 3 markets, and they provide these horizontal capabilities to interoperate between devices and applications at the IoT edge. Okay, it's, I think, in the 2.3 release, so been operational for over 5 years, and this is a very mature project, very deployed project, right? A lot of things have been implemented, whether it's in smart cities and new buildings or in retail across the Open Retail Initiative, where the frameworks operate, ingest data from cameras and things like that, right? And of course, in manufacturing from multiple source. Okay, so that's EdgeXFoundry. Its sister project called Fledge is similar framework abstracting, but there are two important differences. The first difference is it's much smaller footprint, so it can actually go into the embedded compute type user edge, as we call about the very left. And number one, and number two, it has connections and tie-ins with TensorFlow and for AI ML work that you can actually utilize. So it's connecting the industrial data pipelines, right? Integrating OT and IT so that you don't get the silos. And then your use cases are classic, anomaly detection, ML, AI ML, predictive maintenance, condition-based monitoring in the industrial. And again, the architecture is the same, right? Microservices abstractions that are pluggable that can connect to sensors or PLCs. And it's all REST-based, right? So it's fairly straightforward. And it has also issued a release 2. This project just graduated to a stage 3, stage 3 being, very mature. Okay. The one additional thing that Fledge has done is it has also included a use case in the energy subsystems for sort of sitting between the distribution systems and the transmission systems at the edge. And it is also integrated into the energy subsystems as we get into the scaling and the open sourceification of the energy subsystem. So this is an important project as well. Eve is very rapidly growing and moving to probably a stage 3 very quickly. But there is something called an Eve OS, where it's a Linux-based OS for distributed edge computing. And what you do is you kind of consolidate container and VM-based workloads, and you deploy it on the same IoT Edge hardware. But then security is out of band, analytics is out of band, and it's built on an assumption that you may not have connectivity all the time. And so can you have a lightweight version of OS? Can you have a lightweight version of all the networking functions, right? Can you have a lightweight security functions, right? Root of trust. Can you do lifecycle management, zero touch onboarding, right? Things like that. In case the cutoff is there from a connectivity perspective. But obviously, this. And by the way, this was contributed by a startup called Zedata, which is one of the Silicon Valley's company, and it's growing quite well into the industrial space. Home Edge, there was a Samsung contribution, but it is kind of mature enough to unify the gateways on the home. I won't spend too much time on it given the audience here, but if you need something in the home, you have a project like this. Open Horizon, contributed by IBM. That project is really intended at a very simple use case, which is, can I manage the models and container workloads in the constrained devices across the huge deployments and scale of the edge, right? So it's running all these containers in multiple areas and provides that lifecycle management across these containers. Okay, and I won't go into all the details, but let's say you have a workload and you have a model and you have a fleet of things, right? That is deployed in multiple environments. So let's say 10,000 nodes or low. How do you go into each of these and kind of scale properly, right? Like, so it's tackling the container management of at scale. Okay. And then I talked about this, you feel free to download this report, very important. It is actually done through the community research. And so while we're not like a traditional Gartner analyst or things like that, it is the developer's voice and where the market's heading from an open source perspective, open source and non-open source perspective. That's the State of the Edge report. It will be refreshed this summer. And then some of the newer projects like Alvarium, very interesting, right? It's a very point solution, but how do you build a framework of trusted fabric so that the data is delivered with trust from devices to application? And you have a confidence score, you have a confidence interval, right? How do you prevent privacy, maintain privacy, prevent fake data, AI generated, and of course, GDPR compliance, right? Very important in this part of the world. So this project is intended to that with all the SDKs. And I think Dell donated this, but it's grown in size as well. So I won't go into how the data confidence fabric is quantified, but there's a backend mechanism by which you can get these scores, and you can have confidence that these things can go properly between source and the application. Okay. We're currently the community is using this for transportation, energy infrastructure, carbon credits, smart cities. So there's an energy angle on Alvarium here as well. Then we head to Beetle. Beetle is contributed by our colleagues in China. As they start pushing Kubernetes and cloud management from sort of the cloud up into the edge compute all the way down, how do you manage it? A light, secure, scalable edge application, drones, drone processing, inspection of AI, video images, right? Et cetera, et cetera. And it's set up for, as I said, hardware agnostic, OS agnostic, right? So worked with all the hardware. And it's in the second release and integrates with many of the other projects. So this is an important, interesting project that has been developed. And then eKuiper, again, very specific use case on IoT data analytics, runs on a resource constrained edge device, right? Very small footprint. And then FIDO, as we call it, it used to be called SDO or secure device onboarding, Intel contribution, but it is kind of as these devices get deployed and ODMs can actually build these devices inside and kind of ship it so that it is consistent and secure. Okay. So that's a very, very quick overview. I'm sorry for going so fast, but I wanted to make sure we have time for discussions and Q&A. But if you have not already done it, you can start participating in the Linux Foundation Edge projects, right? Just get an LFID just so that you can enter all these wikis and then just join the TSCs, contribute, code, whatever you want to do. Okay, so that's my quick update, and I'm going to stop sharing here and take questions. Rosaria, were there any?
Thank you.
While we were talking?
No, so far, no. I told you I will stop you, but no, no questions so far. So I found on myself very interesting the part of energy and the environment that you also mentioned very quickly, because this is a very new topic, let's say. So I don't know if also in the audience they are considering this in their development. So this is something that
there is a very good overlap and a use case between edge IoT and the energy domains and the energy subsystems, right? Because remember, and so we have our sister organization that I'm also running right now called LF Energy. And what LF Energy is doing is it has about 25 projects that is trying to work to help open source the distribution, the transmission, and then the access systems. And so there are projects like smart meters or projects like EE charging or grid automation, right, from an energy perspective, pure energy. But then there's the intersection of edge and IoT, with smart meters and some of the energy devices. And so Fledge is a major project that has crossed the boundaries between edge and energy, right, as in a vertical use case. And I know it is very important. So folks like RTE, from France are leading, and Aliander from Europe, right? So it's a very EU-led project, subfoundation, which is LF Energy. And we are crossing the open source projects across the two. Okay.
Yeah. Also,
sorry, if there's no questions, we don't want to hold everybody.
no, that's fine.
Hello.
Yes,
Hi.
yes.
Hi, this is
Okay.
Vasilis. Okay, because this was a lot of information, so that's why maybe all the people are
Everybody's
thinking
quiet, right?
Yes, it was a lot of
Or
information.
maybe
And
I want to say that maybe you, Arpit, was so clear that everything is fine.
oh,
That could be also
Rosaria,
because for me it was
clear.
very clear. Yeah, it was perfect.
It was very clear, yes, but although it was very clear, it was quite a lot of information. And although we had come across some of the applications and the frameworks presented here, we had not a close look to all those, and there's quite a lot. And so we try to get information now and try to make some combinations and relate it to our work we are doing. And so what I would like to try to ask is, okay, I will not go into details and technical implementations about some platform or application or framework, but we saw that there were, let's say, like to divide the applications and the frameworks from user edge, as it is named now, to service provider edge, and some applications more close to the user and to the IoT, and other to the edge, to the user edge, and then to the service provider edge. And so these applications are like divided per domain of interest regarding to how close to the edge are they and what they have to orchestrate there. And what I want to ask is there some vision or perspective that these applications are somehow combined regarding their data management, the orchestration of the services, and they in some way can be combined to provide a continuum in the management orchestration of services and data from, let's say, to the IoT to the cloud? Or it is that if you want to go to the IoT, there are some 2-3 applications that you can develop and leverage for your home, let's say the home application. If you are a more provider, like a kind of provider, and you are somewhere in the service edge, you can use this application for this kind of orchestration. Now, if you are a cloud provider, you can go to, let's say, not Akraino or whatever is more above in terms of moving from the IoT to the provider. So is there any thoughts that in somehow they can be as an ecosystem or some of these big groups together to provide a meaningful and useful orchestration from the cloud to the IoT, let's say?
Right. So that's an excellent question. And I think that is where the problem has not been solved yet. And I'll tell you the two problems that have not been solved. The one problem that has not been solved is on the right-hand side. So it has nothing to do with edge, but it's the multi-cloud domain orchestration and I would say multi-cloud data, API, and management, right? If you have an application that connects to, say, an Amazon, the security connection, how you do TLS and how that whole thing connects is different from a Google Cloud. It's different. So there's a multi-cloud application alignment, which has nothing to do with edge, but that's missing, right? So that work is going on in LF networking and some of the other projects with our partners of the major crowd, right? The problem that has been solved is the cloud to edge API through the PCEI blueprint, as I called it. So that one has been solved. And then what has not been solved, and I don't think it will ever be solved, is and I'll show you maybe I'll show. So if each of these projects and each of these verticals have highly specific implementation of the apps, right? Because they have to fit into that memory footprint. And so as long as I'm doing the right APIs on the northbound, if I start putting orchestration in the IoT gateway or even in the constrained device edge, it will not fit. Like Kubernetes is too big on most of these deployments, right? So you got smaller footprints of that. And so you can't put in orchestration and you can't put in. So it's going to be solved in a different way where all you do is abstract the southbound, abstract the messaging, right? So southbound is like maybe 20, 25 ways to get in, right? Through. So I'm just talking about common things, right? Common things across all verticals, right? So abstract the physical southbound, abstract the messaging, right? REST or Modbus or MQTT, Zigbee, whatever, right? SNMP. Abstract that, provide a set of lifecycle management services, and then connect to the cloud, right? But not push a lot of cloud type orchestration down into the edge because it just won't fit. That's what we are seeing. Now, if you can solve that problem, then that's fantastic.
Oh, nice. Thank you.
Yeah. Okay, other questions, or are we good to go?
I think
And one detail more. Okay, I see the point, but you say you abstract the messages, the let's say the channels, the exchange channels. Do these applications or the applications that are more closely located, moving to the IoT, let's say, abstract the messages in type of semantic, some interoperability of, so you know that if you implement it, REST or MQTT or whatever to exchange messages between data stored in an application and data recorded in another application, they can be exchangeable, the data that they handle in terms of either in the semantics of the topics or the exchange or the data format or the semantics, or you have to make translations if you want to extract from one and to go to the other.
No, actually the data, okay, so I won't go into too much detail here, but you can see the metadata and the core data are services provided by these kind of frameworks, right? So you can actually, you don't need to go outside the IoT gateway because you can actually loosely couple the services and the abstractions tied to the data. So no, data part is included.
Okay, thank you. Thank you.
Yeah. Okay, what else?
don't know.
No? Okay.
No, I don't think. I think we are good.
We're good, thank you.
Yeah, I thank you again. I thank you also I thank also the audience to be here. So thank you guys. We will keep in touch.
All right.